student finds some information about energy-saving light bulbs. A 30-watt light bulb uses 600 joules of electrical energy in a certain period of time. In that time, it produces 450 joules of light energy. The rest of the energy is wasted. Calculate the energy wasted by the light bulb in this period of time. What happens to the energy wasted by the light bulb? Calculate the efficiency of this light bulb. Calculate the period of time in seconds during which the 600 joules is provided to the 30-watt light bulb. A company that makes light bulbs provides information about some of their products. The table below shows some of this information. Filament bulb, LED bulb, power in watts, lifetime in hours, cost of bulb in pounds. Suggest why it is important to confirm this information independently. A homeowner is thinking about replacing his filament bulbs with LED bulbs. A 12-watt LED bulb gives the same light output as a 60-watt filament bulb. Suggest reasons why the homeowner is likely to choose LED bulbs. Use the information given in the table. State one factor other than efficiency that is important when considering the choice of a bulb for light in the home. The student investigated the properties of 3 types of insulation. Figure 1 shows the apparatus the student used. Temperature probe 2, temperature probe 1, hot metal plate kept at a constant temperature, insulating material. In the investigation, different insulating materials were placed in contact with the hot metal plate. Temperature probes measuring the temperature on each side of the material. The temperature probes were connected to a data logger. Figure 2 shows how the temperature measured by temperature probe 2 changed over 10 minutes for each of the materials. Time in minutes, temperature in degrees, material A, B, C. What was the temperature of the hot metal plate? Which material was the best insulator? Tick one box. Give the reason for your answer. Another student repeated the investigation but doubled the thickness for all 3 insulator materials. Suggest how using thicker insulation would affect the results of the second student's investigation compared to the first student's results. The students could have used a thermometer instead of temperature probes and a data logger. Figure 3 shows the data logger screen and a thermometer. Data logger screen, magnified view, thermometer. Give 2 advantages of the data logger and temperature probes compared to a thermometer. The table gives information about 4 types of insulation that could be used for insulating the cavity walls of houses. Type of insulation: felt wool, mineral wool, polyurethane foam, rock wool. Thermal conductivity in watts per metre degree Celsius. Explain which of one of the types of insulation in the table would be the best to use for cavity wall insulation. Diagram shows a tennis ball being thrown vertically into the air. At position C, the ball has just left the tennis player's hands at a speed of 5 meters per second. The tennis ball has a mass of 0.058 kilograms. Write down the equation that links kinetic energy, mass, and speed. Calculate the kinetic energy of the tennis ball at position C, kinetic energy. At position A, the tennis ball is at maximum height. What's the gravitational potential energy of the tennis ball at position A? Ignore the effects of air resistance. At position B, the tennis ball has 0.38 joules of gravitational potential energy. D. Write down the equation that links gravitational field strength, gravitational potential energy, height and mass. Calculate the height of the tennis ball above the player's hands when at position B. Gravitational field strength is 9.8 newtons per kilogram. Height. A student set up the electrical circuit as shown in the figure below. The ammeter displays a reading of 0.1 amps. Calculate the potential difference across the 45 ohm resistor. Potential difference. Calculate the resistance of the resistor labelled R. State what happened to the total resistance of the circuit and the current through the circuit when the switch S is closed. A student used the apparatus in figure 1 to obtain the data needed to calculate the specific heat capacity of copper. Joule meter, immersion heater, copper block, thermometer, 12 volt power supply. The initial temperature of the copper block was measured, the power supply was switched on, the energy transferred by the heater to the block was measured using the joule meter, the temperature of the block was recorded every minute, the temperature increase was calculated. Figure 2 shows the student's results. Temperature increase in degrees Celsius, energy transferred to the copper block in joules. Energy is transferred through the copper block. What is the name of the process by which energy is transferred? Conduction, convection, radiation. Use figure 2 to determine how much energy was needed to increase the temperature of the copper block by 35 degrees. The copper block has a mass of 2 kilograms. Use your answer to part B to calculate the value given by this experiment for the specific heat capacity of copper. Give the unit. This experiment does not give the correct value for the specific heat capacity of copper. Suggest one reason why. A student wants to calculate the density of the 2 objects shown in the figure below. Metal cube, small statue. Describe the methods that the student should use to calculate the densities of the 2 objects.